Okay, so hello, WizzDev software development practices. This is a review of our practices, but it applies to life science companies and embedded software companies. We'll see how this goes. We'll start from a big explosion, a big collision that happened a long time ago. It was actually a time when a lot of software engineering practices were actually bubbling and just emerging. There was something called extreme programming on the horizon. Agile methodologies were forming or being created. Now we are more familiar with Kanban. Or Scrumban. What has happened is that extreme programming (XP) has collided with Scrum and Scrumban, and all those methodologies are forming what most people use right now, a combination of that. So what do I mean by this? Extreme programming was much more focused not only on project management practices, but also on the craftsmanship of the code itself. So we had a lot of the things that we take for granted nowadays formed around this time, or like reformed in the agile practices. Yeah. So things like pair programming, code reviews, continuous integration, small releases that can be easily developed. Specifically, collective code ownership, planning games where you say, poker games where you say how much time or points a given task is going to take. This is the root of those practices is in extreme programming. And nowadays, a lot of people mainly talk about Scrum and Kanban, but a lot of those technical hands-on practices are taken for granted. But they are quite important to get productivity high and also happiness on the projects. Yeah. So we'll talk about them, how they form, and also how this kind of relates to what WizzDev is doing and what embedded companies are doing, life science companies are doing with their products. Nowadays, Scrum is just like a surface high-level methodology for managing scope, requirements, what has to be done, and it actually tries to guarantee that the most important things are delivered first. Yeah? But it's been always combined with a good programming practices, so coding standards, simple design, sustainable pace, so the teams can work in multiple iterations at constant speed, or like as much constant speed. Yeah? This shows you how they work together. It's not replacement, it's working together. There's a lot of talks around Scrum, but today we'll try to focus on this oak of egg, so the core of the software engineering practices. And why? Because it makes sense. Yeah, a lot of the studies show where fixing bug costs the most, or like where doing any work costs the most. If we look at the phases of a product, yes, in design, implementation, testing, and maintenance, the most expensive is finding and fixing a bug in maintenance. That's why there's so much emphasis around capturing the correct requirements and what needs to happen in the design, because the ratio is 1 to 100, so it's massive. But it's quite often overlooked that a lot of bugs and problems happen during implementation and during testing. Yeah? So while it's essential to use good feature definition, good story definition, story points to have essential input with your requirements, what we're going to be trying to emphasize is that during implementation, those practices really matter. So and in testing, yeah, because they really still are much cheaper and much more effective and make people more happy than finding problems during maintenance. We have multiple different practices. During the analysis, we have technical proposal, down definitions. In design, we're breaking down the proposals into small chunks and higher level architecture. In development, we have code reviews, frequent commits. In testing, there's a lot of practices. Yeah. What's important is to strike a good balance for each project. If you are a life science company that is just trying to get, say, your first instrument to the market, so it just works, yeah, so it's good enough or barely works, then it's a different practices than you would have when you're trying to build a medical device grade software, yeah, and it just always works and never harms a person. Yeah? Likewise, with if you're developing just proof of the concept POC device that has sensors, and you just want to show that it works in principle, then it's a different story when you're developing already a product with hundreds of thousands of devices deployed to customers. Yeah, so we will try to assess ourselves with WizzDev and show how this could be used for assessment of other teams, products, or companies. We have simplified this into a few areas. The design, implementation, and maintenance. This allows us to simplify it for you. Internally, we have a little bit more extended list. Yeah, so we'll start from top. We'll try to go quickly through those areas. So in the design, we have technical proposals for everything. For everything we do inside the company and outside company. Yeah? So we write a technical proposal with some short business scope, what problem we're trying to solve, what is this module or application is trying to do, perhaps are there any other solutions, and then we use that as an input for anything we do in WizzDev. Yeah, that implies for our internal projects that we do a few, but also most of our projects are external for our clients. Every project starts with that, and the aim of that is to estimate the project or the module in hours and break it down into modules and tasks in that document. And that's the initial input, but also lists the risks. Yeah, so that's a kind of essential work we do for everything. And then we have task management. That is quite common. We use Jira, but you're welcome to use any other methodology. What's important is to break down your technical proposal into manageable tasks. Ideally, when you start working on a task, the task is no more than 3 days long. Yeah, and that helps you to do Git commits, which we'll talk about in a minute. And once you have those kind of tasks, we have issue tracking. That helps you to find bugs, to help to track bugs and their life. That's quite common. A lot of companies do that. That's part of Scrum and part of Kanban. But it's quite important how you link it up with the source code development testing, yeah, which we will talk in a minute. Then we have a high-level architecture diagrams. So they are part of technical proposal. We're trying to have everywhere always high-level architecture diagram or diagrams, simple enough that can be understood by all business stakeholders. So customer of our client should be able to understand what we are trying to do. Also, our technical team should get some information from that high-level architecture. Yeah. So that's the simple input for for all of the stuff we do at WizzDev. And then version control. All of the code is in Git. That's a fundamental rule. Even if we do just something like a proof of the concept, even if we do just an internal tool or just play, we create a repository, or we have a repository with our own internal projects, and we always keep everything in Git. We push things frequently to this Git. We do code reviews. We actually follow what's called Git flow. So that's a process that was invented by Linux Towards, the same person that is author of Linux and is still the main contributor and person that merges all of the changes. And he was quite frustrated with managing those changes. So he invented Git. And Git flow is the process to use Git. So if you've been using Git and you haven't heard about Git flow, please look it up. It just says that there's a master, there's a devel branch, and there are feature branches and how they work together. Yeah, we'll have a separate session about Git flow and about merging, and also we'll have a separate session about code reviews and coding standards. We also embrace collective code ownership. It means that all of our Git is online. We really emphasize ability to work from anywhere. So we can let our clients to connect to our Git and contribute, or we can connect from the office, or we can connect from home. You can have your corporate Git inside your building, but it should be accessible for anybody that you work with, including your internal people and external people. Of course, you manage who has access to what. Yeah, and ideally you have a high level of ownership. So most of the repositories are visible to all of your internal employees. So they can look each other's code all the time, and they can learn from each other all the time. You're doing quite often commits. Commits no bigger than 100 lines of code. 100 to 200 lines of code are manageable, and you're doing them according to some coding standard. Yeah, so you either download one from Google. There's lots of really good coding standards for C++, Python, Java, JavaScript, or you create your own one based on derived from those coding standards. Yeah, we'll have a separate session about that. Unit testing is a core. This really gets to this testing blue square. The more you discover things in testing, automated testing, the better your chances of not finding the bug in maintenance in production. Yeah, and you have also environment management. So you just don't do everything in production. You have a separate environment for development, separate for testing or staging, and separate for production. You may have more environments, but you never work directly on your product or on your customer kind of system. Yeah, and you're trying to build automated testing that help you to test things rigorously, regularly, at high volume, including performance testing. Yeah? What's really good practice is manual testing before merge. Actually, this is quite hard to achieve, and it's really holy grail. So before the code is merged to main branch, it's not only tested automatically, which is possible, but also manually, potentially is tested that feature. Yeah. So when you're merging, you know it's in principle it did work before the merging, and does it work after the merging. Yeah. For that you need really environment management at high level. Yeah, at high quality. And then we have this is all built together with continuous testing, continuous integration. Here at WizzDev, we really embrace the DevOps culture and being able to build things all the time, rerun the tests, and have continuous integration servers for all projects that we work on. And being able to integrate that with either customer system or our other parts of system as frequently as possible. Yeah, and frequent releases. Yeah, the more frequently you release, that's the core of extreme programming. The less likely you're gonna have so many bugs that will be overwhelming for you. Yeah, so if you release every every year, then there may be a chance that that release have so many bugs that once you put it into production, it'll be hard to figure out what actually went wrong. But if you release every day or every month, every couple of days, then the chances are that there's just few things that went wrong, and you will be able just to roll back just a small change. Yeah? So frequent, often releases. I know that big platform companies release all the time from multiple teams, but that's really kind of at the extreme. Yeah, but you should aim for frequent, often releases. So where does the WizzDev stand at this scale? I might say that we don't strive for having all at highest possible rank. Yeah, we also are trying to improve our kind of practices. At the moment, we have definitely technical proposals for everything. We have task management for everything and issue tracking. There are still several areas where we don't have high-level architecture diagrams, but that's changed, and our plan is to embrace more architecture-level diagrams templates. So we have templates of diagrams, our internal ones, the most frequent problems we face, and they help to create that diagram much faster. Yeah, that's why we're improving, and we're hoping to get that to usual shortly. We do everything in Git, and everything is in Git. That's really core. That's what every organization should really use as a baseline. Yeah, there's no excuse for that, and there's usually grave consequences if somebody has something in zip files on somebody's computer or on some hidden storage, and nobody can review that. Yeah, it usually means that there are some hidden bugs or hidden areas that they will come back when it's code reviews. We do code reviews on all of the repositories. Collective code ownership, we try that, and we do it most of the time. Of course, there are areas like the code is owned exclusively by the client, and he said that only one developer from our team can own that, or there's some exceptions. Yeah, but here we really have to be accommodative to clients. but we really strive to improve here. Yeah. Frequent commits, that's something that we do on all of the projects. No reason not to do that. Coding standards we have established for key languages like Python and C++, but there are still areas that we need to improve, especially when the language itself has released a new release. Yeah. So there's going to be a separate session about coding standards, similar to unit testing. Ideally, unit testing coverage should be quite high. That's why we haven't give ourselves maximum score here. We don't say we have everywhere maximum possible unit testing coverage. That's really pragmatic, and that usually depends on the client kind of budget to actually pay for this unit testing development. Yeah, in the long term, this is the best investment, but sometimes when the client needs MVP to be released, then of course high level of unit testing might be just counterproductive. So this is case by case, but we do that everywhere. Yeah? And we have environment management for all of the projects that have production release. And automated testing is at the core of our development. Manual testing before merge, I would say that we just sometimes use that. Yeah, this is mainly because we have always new projects. Creating a really high number of environment ad hoc is non-trivial, and we really strive to find a way to do that. That would mean that we can ad hoc, on demand, create environment that has only specific feature in it, specific branch with that feature, and we are able to give it to tester to test just that feature with on dedicated environment. Sounds simple, but it requires quite a lot of DevOps time. Perhaps we'll get there one day. Yeah? And we definitely want to have CI/CD on every project, even the simplest one. So that's our target. Integration and system tests, they are much harder to develop than just automated unit tests. Integration and system tests take time to develop, also take time to maintain. Yeah, so we're striving good balance between what's in the budget from the client and what we'd like to do. Yeah, and finally, frequent releases, we definitely do that frequently, and frequently releases. There may be areas that need improvement. I think this is the easiest to improve. Yeah, so that's a quick one. Thanks for taking part in this session, and we'll follow up with more to come. Thanks.